All right, all you remote people, whoever you are, we're going to be extending some geometric sequences today. I know it's super exciting, super fun. All right, so a geometric sequence, basically, in arithmetic, you're adding the same number over and over and over again to a sequence, but in a geometric sequence, we're multiplying what's known as the common ratio over and over and over again. Now, I'm going to write down the formula for geometric sequence, which is A subset n equals the first term, so we got the first term, it's A1, multiplied by what's known as the common ratio, and then n minus 1 represents your previous term. All right, like the n is the nth term in the sequence. So right here, here's our A1, all right? And then this is our second term. So this is our first term, this is our second, this is our third. We're just trying to find what's called the next term. Now, if you want to find the common ratio, it's very, very, very easy. You just take one term and divide it by the previous term, and that's how you find your common ratio. So I'm just going to do 15 divided by 75. You could also take 75 divided by 370, not 335, sorry, 375. All right, and then you just reduce it. All right, so let's think about this. What number goes into 15 and 75? I would say 5 goes into it. So I'm going to divide that by 5 and get 3. And divide that by and get 15. All right. Oh, 3 goes into 5. So 1/5. Look at there. So it looks like my common ratio is 1/5. All right. So you could just take, like I said, you could take 15 divided by 75. All right. There you go. You can see it's 1/5. So what am I going to do with this 15? I'm going to multiply it by 1/5, and a fifth of 15 is 3. So I'm just going to type in the number 3. Before I do it, I got to put 1/5 here too, because these are the same. All right, let's see here. All right. Oh, this one's a little bit easier. All right. You can kind of see what's happening. What's 15 divided by 5? 15 divided by 5 is 3. So all I got to do is take 45 and multiply it by a 3. 15, carry the 1. That's 12 plus 1 is 13. So 130, 135. If you're using a calculator, you just put 45 times 3. Still get it. All right. See how easy that is? Super easy. I don't even needing to make a formula. All right, so that's all you got to do. All right, is just take this term and divide it by the previous term. All right, so take any two terms, take this one divided by the previous one, you get your common ratio. That's extend geometric sequences. All right, let's go over here. It says extend geometric sequences with negatives and fractions. Well, you do it the exact same way. All right, so it's not a big deal. You can take any two. So I'm just going to take these two right here. All right, so I'm going to take 6 over 5, and I'm going to divide it by negative 3 over 5. Now, if you were to do this, it's like multiplying it by a reciprocal. All right, so I divide, multiply by reciprocal, multiply it by a reciprocal. So these 5's cancel out. 6 divided by 3 is 2. So we're basically multiplying everything by negative 2. So when you take 6/5 and you divide it by negative 3/5, that's like saying 6/5 times the reciprocal of negative 3/5, which is negative 5 over 3. So that's what I was doing. Okay, so that's a negative 2. So all I'm going to do is just take a negative 2 and multiply it to this guy. So negative times a negative is a positive, so it's 24 over 5. So I'm going to type in 24 over 5. Now, if you're doing this in a calculator, here's what you would do. Okay, calculator. You do a parentheses. 6 divided by 5, and you divide it by the previous term, and the previous term was negative 3/5. So put parentheses, negative 3/5. Oh, better put a negative 3 there. All right. And you can see it's negative 2. Now, some students like the whole alpha y equals, but it kind of gets ridiculous because you got like an alpha y equals, and you got to do another alpha y equals enter, and then you got to do a 6 over a 5, and then you got to go down here and do another alpha y equals enter, which is just looks ridiculous after a while. But you can still do it this way too. You still get a -2. All right? All right, so let's go ahead and put that -2 right here. Oh, no, not -2. 24. That would have been bad. See how it says your answer should be a fraction? Ours is going to be an improper fraction because we're kind of improper here. All right. Trust me, if you're in my class, you would know how improper we are. So 24 over 5. Nailed it. Let's do one more of these guys. All right. So what's the next term? All right. So we're going to take 36. We're going to divide it by 54. All right. So all you do is just take 36 divided by 54. All right. That gives us 2/3. So that gives us 2/3. These are both divisible by 18. If we were doing it by hand, that gets us 2/3. So what we have to do is we got a 24. We got to multiply it by 2/3. Well, 3 goes into 24 a total of 8 times. 8 times 2 is 16. So 24 times 2/3 is 16. So I'm going to put a 16 there. All right, let's do one more. Now, you could take 8 and divide it by -16 over 5, but I'm going to make it a little bit easier. I'm going to take -20 and divide it by 8. I'm going to reduce that fraction, okay? So negative, that divisible by 4, so that's 5, divisible by 4, so that's 2. So our common ratio, our R value in this one is -5 over 2. So I'm going to take -20, I'm going to multiply it by -5 over 2. Now, a negative times a negative is a positive. I basically get 100 over 2, which is 50. But you could also do it this way. You could say, hey, 2 goes into 20 10 times, and 5 times 10 is still 50. So I'm going to put a 50. Now, why am I putting a positive 50 instead of a negative? Because a negative times a negative equals a positive. That's why I'm putting a positive 50 right there. There we go. That's all you do for that. So now what we have to do is find what's called the fifth term in the sequence. So this is going to be really easy. All right. So they've given you the formula. All right. So this right here represents the first term. Okay, that's the first term. So if you're wondering what the formula is, you're like, what formula are you talking about? I'm going to go ahead and zoom in real quick. Maybe you'll write it down. Maybe you won't. It's up to you. Okay. So I'm going to zoom out just a bit. There, you can pause it. You can pause the video and write this down in your journal if you want it, just to have it. You could write that down. There it is. Pause the video, write it down. I'm moving on. There we go. All right, let's go back over here. So on this one, it says, what's the fifth term? So literally, I just got to plug in the number 5. So in the calculator, you could do -1, 2 to the power of 5 minus 1, which is 4. Well, 2 to the power of 4 is 16, and 16 times -1 is -16. So the fifth term is going to be -16, and that's what I'm going to trust is the right answer. -16. All right, let's look at this next one. This one, same concept, little bit different way of doing it. Okay, so they've given us the common ratio, which is a half. They've given us the first number, which is 56. So I'm just going to do this by hand and just make it without having to do a formula. Sometimes logic is easier than using a formula. So I'm going to take half of this guy. Well, what is half of 56? That's 28. What's half of 28? That's 14. What's half of 14? That's 7. What's it looking for? The fourth term. This is the first, this is the second, this is the third, this is the fourth. Boom, I'm done. I'm typing into 7 and calling it a day. Okay. All right, so now the last thing we're going to do here, well, actually 2 more things. We have called the explicit formulas for geometric. No, this is not for TV mature audiences. We're not having explicit lyrics or anything like that. This is just dealing with specific formulas for a geometric sequence. So listen up. This is your first term. Okay. How do we find our R value? You always take this term and divide it by the previous. So it makes it very, very, very easy. Our R value is 60 over 120, which equals a half. So our R value is a half. Our first term is A1, which is this one. So we're going to write 120. That's our first term. Then we're going to multiply it. So I'm going to do parentheses. I'm going to plug in a half. and then I'm going to raise it to the power of n minus 1, just like that. So I'm going to see if I can type that guy in. See how it works. 120 is our first term. I'm going to do parentheses, which is our r value, and I'm going to do 1 divided by 2. But then I got to raise this to a power, and I got to put n minus, oh, okay, so how do we do that? I think we might have to use parentheses up here. Parentheses n minus 1, like that. Okay, so let's see if that works by putting in the parentheses to keep it up there in that power. Okay, so I'm going to pause the video because I got to make sure all my students know they use parentheses up there. All right, moving on to the next question. All right, oh, it looks like we got a couple of people here trying to figure stuff out. Woojin and Kieran. All right, so we got a formula. You know what? I'm not even going to look at their answers. I'm going to make my own formula because my formula will be right. So I'm going to say f of n equals my first term, which is 64, parentheses 16 divided by 64 is 1/4. Oh, look at there, 1 over 4. 1/4 to the power of n minus 1. This is the correct formula, which means Kieran is right and Woojin, I'm sorry, you are wrong in this particular case. Only Kieran happens to be correct. So I'm going to put only Kieran, okay, not Woojin. And I have nothing against Woojin, just Kieran just happens to be right in this particular circumstance. What? Oh, he put 64! Oh my goodness, they're both right, dadgummit. I hate it when it happens. They're both right. Woojin, I apologize, because this actually works because if you plug it in, they got me, dadgummit. That's okay, I'll be wrong on this, that's fine. If you plug in, listen, if you plug in a 1 right there, that becomes a 16. Oh, wait a second. If you plug in a 1, that becomes a 16. If you plug in a 1 here, that becomes a 6. They're not, neither of them are right. Dadgummit. That was supposed to be the right answer. Neither of them are right, dadgummit. Not both. Neither. Wow, I'm an idiot. That's okay. All right, so this. I actually wrote down the right answer, but that was wrong, and they were both wrong. I didn't notice that was a 16. Okay, listen, because this right here is supposed to be a 64. For some reason, I didn't see that. I don't know why. All right, that's okay. I'm going to get 100. All right. So here we go. Well, I can't get 100 right now, but I'm going to. Our very first term is a half. -4 divided by 1 over 2 equals -8. So I know I'm going to be multiplying everything by -8 to the power of n minus 1. When I get angry, I do math problems fast. So here we go. 1 divided by 2, parentheses, -8, close parentheses, to the power of, parentheses, n minus 1. All right, so that should be it. Nailed it. But you know what? I don't like it, so I got to go back. I'm doing it again. I'm getting 100. I don't care what you guys say. You can fast forward through this if you don't like angry Mr. DeMood. All right, so here we go. Our first term is -1.5. All right. All I got to do to figure out the second term is take 6 and divide it by -1.5. So I'm just going to do 6 divided by -1.5. That's -4. So now I know all I got to do is multiply the next one by a -4. So our formula is multiply everything by a -4. That'd probably be easier if I did -24 divided by 6, which is still -4. All right, next one, our very first term is -0.56. All I've got to do is do this divided by this. So if I do -56 divided by 5.6, that decimal moved over once, so it's going to be 10. But in case you're not sure what I'm telling you, -56 divided by -5.6, you can see that's equal to a 10, which means I'm simply multiplying everything by 10 over and over and over again. All right, let's see here. Let's go over here. This one I start out with 300, and I got to do 60 divided by 300, or 12 divided by 60. Now 12 divided by 60, if I just write it down, 12 divided by 60 reduces to 1/5. So I'm going to make everything multiply by 1/5. All right. And last but not least, we have negative 0.6. All right. Negative 15 divided by 3 is negative 5, so everything's being multiplied by a negative 5. Okay, so there, got that one done. Now let's go over here to sequence word problems. This will be the last thing I talk about today, sequence word problems. All right, so what we have to do is we have to figure out whether it's arithmetic or geometric. Is it something being added to something over and over and over again, or is it being multiplied over and over again? All right, so Daniela received $30 as a birthday present and decided to save her money to buy a new video game. All right, from the following week onward, she added, so that's the key word. What did she do? She added $12 to her savings every single week. If you're adding something, that means it's arithmetic. All right, so we know that's the first part. It's arithmetic. Now it says complete the recursive formula. So what is our very first term? What did she start with? She started with 30. So she started with $30 because she received it as a birthday present. And what is she doing over and over and over again? It's being, hold on, added. What's being added? A total of $12. Okay? And that's how you do these. Okay? So I'll go next question. This one says, Achilles ordered a pizza with 16 slices. Every hour he ate half of the remaining slices. Let f of n be the number of slices Achilles ate and nth the hour since he got it. So this is not arithmetic because he's not eating 8. Yes, he would eat 8. He's eating half of the remaining slices. All right, so first of all, this is geometric because we are not subtracting. We are simply what? He's eating half. So our R value is 1/2. So he ordered a pizza with 16 slices. So he had 16 slices. All right. Now, I'm going to put right here. After the first hour, all right, remaining slices, he ate nth hour since he got it. So listen, when that was 0 hours after he got it, 0 hours after he got it, he had a total of what? 16. But after he had it for 1 hour, it's down to 8. And then after he had it for 2 hours, it's down to 4. Okay? So it's definitely geometric, but we got to be careful in writing this explicit formula because technically, after the first hour, he's already down to 8. So I'm going to see what they want, and if I get this one wrong, at least you guys will learn from me getting it wrong. All right. So I'm going to type in geometric. All right. And then he ordered a pizza with 16 slices. Every hour he ate half the remaining slices. Let f of n be the number of slices he ate in the nth hour since he got it. So the nth meaning, like if you plug in a 1, all right? If we plug in a 1, what should be the first term? He should have what? 8. If he plugs in a 2, it should be 4. If you plug in a 3, it should be 2. So I'm going to start my first term with 8. All right? Or I could start with 16 and do 1/2 to the power of n without doing n minus 1. Maybe I'll do that. Let's see if that works. I'll start with 16, and when I plug in a 1, I'll get in 8. I'll try that. See what happens. 16 to the power of 1/2, and then I'll just raise it to the power of n. Where is it? Raise it to the power of n and see if they accept it. They do. Oh, look what, see, you couldn't put n minus 1. I wonder if they'd also give you the other formula you could have written for this is, you could have written 8 parentheses 1/2 to the n minus 1. Okay, you might have been able to do that. Let's see what they did. Oh, they did it this one. See, 8 times n to the power of n minus 1, which is the same as what I did, which was 16 to the power of 1/2 to the power of n. These mean the same thing. That's a tricky one right there. All right. Zhang Li tracked the size of bear population in a nature reserve. The first year there were 1,000 bears. Sadly, the population lost 10% each year. Okay. So if it's losing 10%, it's being multiplied by a factor. Ready? So what do we start with? 1,000 bears. If it's losing 10%, what's it keeping? Yeah, so what does it do? It keeps what? It's keeping 90%. Well, what's the decimal for 90%? 0.9. So I'm going to put 0.9. That's kind of tricky. I like it. Okay. After what? N minus 1. So this is another geometric sequence. All right, that's a geometric sequence. So we start out with 1,000 bears, and then every single year that previous term is going to be multiplied by, it's going to be multiplied by 0.9 because it's losing 10%, so we're keeping 90%. Is it not? It's not 0.9, or how about this? Is it supposed to be 9 over 10? Oh, forgot geometric. Okay, thank you. I forgot to hit geometric. There we go. So geometric n multiplying by 0.9. Yay! All right, last one. Maybe. All right. So Olivia read a book. She started on page 20, and each minute she read 3 pages. Let g of n be the pages that was on the beginning. She was on at the beginning of the nth minute. So what did she start on? She started on page 20, right? If we're adding, right? Each minute she read 3. She didn't read 3 times the amount of pages. She just read 3 pages. So this is arithmetic. We're writing we're writing a formula. So this is making it a little bit harder. So let me rewrite the formula here. So we have a of n equals the first term plus n minus 1 times the common difference. And the common difference is 3, and the first term is 20. So I'm going to put 20 plus n minus 1 times 3. But you could also write it as 20 plus 3 times n minus 1. So that's what I'm going to do. So she's on page 20, and then we're adding 3 n minus 1, just like that. All right. Hopefully this was enough for you to be able to get through all of these assignments. Have a good day.